Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, TIFR, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 20th of the mathematical physics, in which we are going to discuss legendary differential equation. Okay, so before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, so this is the legendary polynomial. Okay, legendary differential equation we are going to discuss. Okay, so legendary legendary differential equation. Okay, legendary differential equation we are going to discuss. Meanwhile, just let me check whether I'm audible. Sorry, legendary. Yeah, I'm audible. Okay, so legendary differential equation. Okay, so I'll write the legendary differential equation. So that is in the form like 1 minus x square d2y over dx square d2y over dx square minus 2x dy over dx plus n into n plus 1 equal to y equal to 0. N into n plus 1 y equal to 0. Okay. Okay, so this is the legendary differential equation. Okay, 1 minus x square d2y over dx square minus 2x dy over dx plus n into n plus 1 y equal to 0, where value of n equal to 0, 1, 2, 0, 1, 2, 3, so on. Okay, 0, 1, 2, 3, so on. Okay, so now we can write this equation in this form. d2y over dx square we can divide by 1 minus x square, so it is going to be 2x upon 1 minus x square. Okay, dy over dx minus plus n into n plus 1 upon 1 minus x square. Okay, y equal to 0. Okay, so from here value of px is 2x upon 1 minus x square. Okay, and the value of qx is n into n plus 1 upon 1 minus x square. Okay, so these are the values of px and qx. Okay, so now from here we can find this limit. Okay, so this is limit x tends to 0, px is going to be limit x tends to 0. Okay, that is 2x upon 1 minus x square. Okay, 2x upon 1 minus x square, and this value is going to be 2 into 0 upon 1 minus 0, that is 0. Okay, and similarly limit x tends to 0 qx will find. Okay, so this is going to be limit n into n plus 1 upon 1 minus x square, x tends to 0, right? And if you put the value, so this is going to be n into n plus 1 upon 1 minus 0. So that is going to be n into n plus 1. So we are getting finite value, right? So, so this means x equal to 0 is ordinary point, okay, is ordinary point for this differential equation, okay, Legendre differential equation. X equal to 0 is ordinary point, okay. Next point. So now I'll tell you so singular point and ordinary point, okay. Singular point means singular for any differential equation, okay. Singular point means either px or qx or both, okay, qx or both, that is qx and px, are infinity, okay. If value of px, either px or qx is infinity, okay, at infinity at x equal to x naught, or at x equal to x naught, if value of px or qx or both px and px and qx is infinity at x equal to infinity, sorry, at x equal to x naught, that means x naught is singular point, singular point, okay. And for this we use Frobenius series, okay. And similarly ordinary point means ordinary point, ordinary point means if px and qx gives finite value, okay, give finite value, like in this case, okay, finite value at x equal to x naught, that implies x naught is ordinary point, ordinary for any differential equation. If px, either px or qx or both are infinity at x equal to x naught, then that x naught is singular point, guys, okay. Ordinary point means if px and qx gives finite value at x equal to x naught, then x naught is ordinary point, and for this we use power series, okay. So this is about that Legendre differential equation, okay. Now this is okay. Now we'll write Roderick formula, okay. Roderick formula, Roderick formula, okay. Roderick formula for Legendre polynomial, okay. Very important. So this is p n x is going to be 1 upon 2 to the power n into n factorial, okay, into dn over dxn, dn over dxn, x square minus 1 to the power n, okay. So this is very important formula, you must note down and memorize it, okay. So p n x is 1 upon 2 to the power n factorial dn upon dxn, x square minus 1 to the power n. So from here we can find value of like p0 for n equal to p0, yeah, or for n equal to 0, this is going to be p0x, this value is going to be 1 upon 2 to the power 0 into 0 factorial and d0 upon dx x0, and this is x square minus 1 to the power 0, and this value is going to be 1. So p0x value is 1, okay. And similarly we can find by this Roderick formula p1 x for n equal to 1. So this is going to be 1 upon 2 to the power n into 1 factorial d upon dx x square minus 1 to the power n 1, right? So this is going to give value x, okay. And similarly for n equal to 3, p2x is going to be 1 upon 2 to the power n equal to 2, guys, okay. This is 1, right? n equal to 2, n equal to 2, n equal to 2 is going to be 2 to the power 2 into 2 factorial d2 over dx2 x square minus 1 to the power 2, okay. So if we solve it, so this value is going to be 1 by 2 3x square minus 1, okay. Okay, so similarly p3x is going to be 1 by 2 5x cube minus 3x, okay. These are very important. We will solve questions and we can easily solve question if we know these values, okay. So I'm going to write it for you, okay. I'm going to write it. So I'll write it in a table. So p0x value, okay, this value is 1. p1x value is x. p2x value is 1 by 2 3x square minus 1, and p3x is going to be 1 by 2 5x cube minus 3x. These are very important. At least you must know these, the p10 value of p1 p0x, p1x, p2x and p3x, okay. For solving questions, you will get questions, okay. So you need to note down and memorize it or remember it, okay. So these are the values of p1, p2, p0, p1, p2, p3, okay. Next, properties, okay. So properties of Legendre polynomial, okay. So properties, okay. So properties are this one: pn1, the value of pn1 is 1, okay. Similarly, the value of pn minus 1 is minus 1 to the power n pn1, okay. pn1, so this is the value, this one, okay. pn minus 1 value is minus 1 to the power n pn1, okay. No, this is just this, okay. This is pn1 value is 1 and pn minus 1 value is minus 1 to the power n, and this is very important property. This is pn minus x, and this value is going to pn minus x is going to be, this value is going to be minus 1 to the power n pnx, okay. Minus 1 to the power n pnx, very important property, guys, you must know. So converting, if you have pn minus x, so you can convert it into pnx by multiplying minus 1 to the power n, okay. So these are the properties. Now I'll write generating function for Legendre polynomial, okay. Generating function, generating function, okay. Okay, so generating function is going to be this one: g, which is function of xt, okay. G, which is function of xt, is going to be 1 minus 2xt plus t squared to the power. So gxt is going to be 1 minus 2xt plus t square to the power minus half, okay. and this value is going to be sigma n equal to 0 to infinity t to the power n pnx. Okay, t to the power n pnx, and where mod t value is less than 1. This is very important. Okay, value of mod t is less than 1. So this is the generating function, guys. You need to note down and memorize it. Okay, and you need to solve questions using this property, guys. Very important one. You get this formula actually in the question. So if you don't remember this formula, still you can solve question. Okay, so this is the generating function. Okay, now the orthogonal condition for Legendre polynomial. Orthogonal condition. Okay, so what is orthogonal condition? So this is going to be -1 integration -1 to +1. This is pnx into pnx into pmx dx. This value is going to be 2 upon 2n plus 1 chronicle delta mn. Okay, so minus 1 to plus 1 integration -1 to +1 pnx pm into pmx dx is going to be 2 upon 2n plus 1 delta mn. Okay, since delta this is chronicle delta mn. Okay, chronicle delta value of chronicle delta mn is 1 if we know, right, if m equal to n, and value of chronicle delta mn is going to be 0 if m not equal to n. Okay, very important. So this is the orthogonal condition for the Legendre polynomial. Okay, well, now we'll solve one question which is asked in CSIR NET June 2017. Okay, so I'm going to write that question. Question is, and this is asked in CSIR NET December 2017. Okay, December 2017. Okay, so the question is GTX is given, guys, GTX, and that is given 1 minus 2xt plus x square to the power minus half. Okay, this is equal to sigma n equal to 0 to infinity x to the power n pnt. Okay, so this is the generating function given, and if fx is given, okay, fx is integration 0 to x fx dash dx dash. This value is x g, which is function of 1x. Okay, function of 1x, and mod x value is less than 1. Okay, then you need to find fx value. Okay, value of fx. Options are, option A is this one, sigma mn equal to 0 to infinity. Okay, x to the power m plus n. Okay, pn1 and pm half. Okay, m plus 1. Okay, option B is sigma mn equal to 0 to infinity x to the power m plus n pn1 and pm1. Okay, and option C is sigma mn equal to 0 to infinity. Okay, x to the power m minus n pn1 and pm half. and option D is sigma nm equal to 0 to infinity. Okay, uh, x to the power n minus m pn1. Options are wrong, I believe. Okay, so let me just check. pn1 and pm half. Okay, these are the options, guys. Okay, so this is the question which is asked in December 2017. Okay, well, so let's solve it. So here we have given generating function. Okay, we have given generating function, that is g g gtx is given. Okay, gtx gtx is given, that is 1 minus 2xt plus x square to the power minus half. Okay, so this is given. Minus half. So here value of gtx is given, right? So we can find easily g1x. Okay, so instead of t, will replace t by 1. So this is going to be 1 minus 2x plus x square to the power minus half, and this is going to be 1 minus x square, 1 minus x whole square, 1 minus x whole square. Okay, if you open it, this is going to be 1 minus 2x plus x square, right, to the power minus 1. Okay, so this is going to be 1 minus x to x inverse, and that is going to be 1 upon 1 minus x. Okay, so value of g1x is 1 upon 1 minus x. So this is the value. Okay, generating function is given. Now in question we have been given integration 0 to x f x dash dx dash, that is given, that is given uh, xg, that is given xg 1x. Okay, so this is given, this equal xg 1x. Okay, so we'll put this value of g1x in the equation. Okay, so we'll put this value g1. So this is going to be integration 0 to x f x dash dx dash is going to be x, and value of g1x we have found, that is 1 minus x, 1 upon 1 minus x, 1 upon 1 minus x. Okay, so this value is going to be 1 upon 1 minus x, sorry, x upon 1 minus x. Okay, next point. Next point, this is now we'll differentiate in both sides, differentiating both sides, because we have to find value of x. Okay, so if we differentiate it, this is integration, and this is we'll differentiate it, right? So this is going to be fx dx. So it's going to be fx, value of fx, right? Fx is going to be, so this is f dash x, right? F dash x. Okay, okay, so this value is going to be, we'll integrate this, so we'll differentiate this, my apologies, so we are differentiating, right? So differentiating means this is going to be like this, d upon dx integration 0 to x f x dash dx dash is going to be d upon dx x into 1 minus x. Okay, so we'll differentiate it. So this value is going to be integration differentiation will give value 1. So this is fx. Okay, value of fx is going to be 1 upon 1 minus x, and then plus uh, x upon 1 minus x whole square. Okay, x upon 1 minus x whole square. So it is just we have differentiated the first function into second function, differentiation of second, plus we have used product rule. Okay, and then second function differentiation of first. Okay, this is the value, and now fx is going to be, we'll take LCM. 1 minus x whole square is going to be 1 minus x plus x. X is going to get cancelled, so the value of fx is going to be, this one, uh, 1 upon 1 minus x whole square. Okay, so then fx we can write 1 upon 1 minus x into 1 upon 1 minus x, 1 minus x. Okay, okay, so then fx is going to be, value of fx is going to be this. We can write this value is, we know this value is this, uh, this 1 upon x is g1x, right? So we can write gm1x into, we can write like this. Okay, gn 1x. Okay, or we can write mn first and then m second. Okay, so we can write like this, and this value we know, this value is sigma n equal to 0 to infinity that 1x, right? 0 to infinity x to the power n, x to the power n. Okay, x to the power n, and this is going to be pn1, right? Into this we can write m equal to 0 to infinity x to the power n pm1, right? We can write this like that. Okay, because uh, this value is this, right? Here this value is this. Okay, this value is this, right? So this fx is going to be, and fx value is going to be this, we can write, this is going to, we'll write combine. So m n equal to 0 to infinity x to the power n plus m pn1, and I'm not sure about options, but this is the correct answer, guys. So this is pm1. Okay, so this is pm, right? So this is the correct answer, guys. Sigma n equal to 0 and m equal to 0 to infinity x to the power m plus n pn1 and pm1. Okay, so this is the answer. This is the value of fx, guys. Okay, very good question, guys. This is the answer. Okay, so which option is matching? So option B is matching, guys. Okay, e to the power m plus 1, x to the power m plus 1, pn1 and pm1, pn1 and pm1. Okay, so this is the one. Very good question. So you can easily solve it, this question. Okay, next question we are going to do. Next question. Next question is, so you need to write a polynomial in terms of Legendre polynomial. Okay, so this we are going to solve now. So polynomial is given, question 2, that is fx is given x square minus 2. You need to write this in terms of Legendre polynomial. Legendre polynomial. from typical method it is going to be very lengthy, but if we know these things, this one value of p0x, p1x, p2x, which I have already explained, right? Then you can easily solve it. So we can write this equation like x square minus 2 equal to its quadratic equation, right? So this is going to be a p0x plus b p1x plus c p2x. We can write in this form, right? Because it quadratic equation, this is constant a, b and c. Okay, a b, so we need to just find out a, b, c, and and then we'll put value here and we'll get the required answer, right? That and then this polynomial we will be able to write in terms of Legendre polynomial. So this is the form of Legendre polynomial. Okay, so how to solve it? Now x square minus 2 is going to be here a p0x value we know, right? I have already explained here. Just check this one. p0x value is 1, p1x value is x, p2x value is, you need to note down it. Okay, 1 by 2 3x square minus 1 and p3 equal to 1 by 2 5x minus 3. Okay, so we'll write it. So this is going to be this is going to be p0 value, p0x value is 1 plus b, p1x value is x plus c, p2x value is 1 by 2 3x square minus 1, right? So we'll write x square minus 2 equal to a plus bx, okay, plus bx plus this is going to be c, this is 3 by 2 c x square minus c by 2, okay, this one. And now we can write like this. We can 1 by 2 is going to be a minus c by 2. We'll write constant together and then px and plus 3 by 2 x square. First constant, then power of x power 1, then x power 2. Okay, so now we'll compare the x constant, x and x cube in both side. Okay, so comparing coefficient, yeah, comparing coefficient of coefficient of comparing coefficient of x square and constant. Okay, so if you compare this first constant, so first x square, so this is going to be 3 by 2 is going to be 1, 3 by this 3 by 2 c, okay, c is there, so 3 by 2 c is going to be 1, so that implies value of c is going to be 2 by 3. Okay, so that is 2 by 3. Next, again we'll compare this value, that x bx equal to, there is no x term, right? Bx equal to that x b equal to 0, right? Because there is no x term, so b is going to be 0. And third constant is a minus c equal to minus 2, a minus c by 2, a minus c by 2, this equal to minus 2. From here we'll find the value of a. Okay, so a is going to be 2 plus c by 2, right? And a is going to be 2 plus value of c is this, we know, 2 by 3, so it is going to be 2 by 3 into 1 by 2, right? This will get cancelled. That means value of a is going to be minus 5 by 2, minus 5 by 2, because this is minus sign. Okay, this is minus 2. minus 2. Okay, so the values we've got, ABC value we have got, so the polynomial is going to be x square, this one, x square minus 2 is going to be this one. We'll put equation here, right? Value of a is minus 5 by 2, so this is going to be minus 5 by 2, this one, p naught x minus 5 by 2 minus 5 by 2 p naught x plus b is 0, so 0, and third is this plus c value is 2 by 3, so plus 2 by 3 p2x, right? So the equation this is going to be, so polynomial in terms of Legendre polynomial is going to be minus 5 by 2 p0x, okay, plus 2 by 3 p2x, okay. This is the required answer. Okay guys, very simple. Next, is going to be next question third. This is, you need to this one, polynomial is given x cube minus 3x square, x cube minus 3x square plus 2 plus 2, that you need to write in terms of Legendre polynomial, okay, in terms of Legendre polynomial, okay, in terms of Legendre polynomial. So we can write it x cube minus 3x square plus 2. We can write in form of Legendre polynomial a p0x plus b p1x plus c p2x plus d p3x. dp3x, okay. So if we have written in terms of, because it's a power of maximum power is 3, right? So it will go till p3. A this is constant, right? A p0x, b p1x, c p2x, and d p3, right? So we'll find value of a, b, c, d, and then we'll put this in equation 1, and then that would be the required the required equation in terms of Legendre polynomial of this polynomial, okay. Well, so we'll put the value. So we know the value of p0x, p1x, right? All I have already written. So this is going to be 3x cube, x cube minus 3x square plus 2 is going to be a into 1, p0x value is 1, plus b into x, value of p1x is 1, oh sorry, x, and c p2x value is 1 by 2 3x square minus 1, and plus d p3x value is very simple, this is 1 by 2 5x cube minus 3x, okay, 5x cube minus 3x this one. Okay, so now we'll simplify it further. So a plus bx plus this is c 3c by 2 x square minus c by 2 plus 5d by 2 x cube minus 3 by 2 d x, right? This one. So this is going to be x cube minus 3x square plus 2 is going to be equal to this one. Now we'll put constant together, right? A minus c by 2 plus b minus x together, okay. B minus 3 by 2 3d by 2 Okay, uh, this is 3d by 2 x plus 3c by 2 x square and plus 5 by 2 dx cube. Okay, so just give me 1 second, guys. Okay, well, okay, so this is going to be comparing the value coefficient of x cube, comparing the coefficient. So if you compare the this is going to be first 5 by 2 d is going to be 1, right? Here this is d, x cube is 1, 5 by 2 d is going to be 1, and so this value is going to be, so from here we'll put the value. So the value of d is going to be 2 by 5, right? And then 3c by 2 is going to be minus 3 for x. Okay, this one 3c x square, this is minus 3, right? So from here next b minus 3 by 2 d, that is going to be equal to, because this is x term, there is no x term, right? So from here the value of b is going to be, we'll put the value of b, so this is going to be 3 by 5, and similarly value of a, this will write a equal to 2 plus c by 2, or from here we'll put the value, so this is going to be 1. Okay, so we have got these values, very simple, simple calculation, you can do it. Okay, one, now we'll put the value. So required equation is going to be, that is x cube plus minus 2 p2x, okay, plus 2 by 3 p3x. Okay, so these are value of abc, right? p3x. Okay, so this equation is going to be p naught x plus 3 by 2 p1x minus 2 p2 p2x plus 2 by 3 p3x. Okay, so this is the required equation. So this is the equation. So we have, this is the equation. This equation is in the form of Legendre polynomial. Okay, this is answer. Okay, so now I'll draw the graph for Legendre polynomial. Okay, so this is like this. This is x and this is p and x. So we know the value of p0x is 1, right? So this is p0x value is 1. So this will be constant if we draw the graph here, right? And similarly, the second value, that is going to be this straight line, guys. Okay, this is straight line actually. This is straight line. Okay, this is for the straight line, and this is for this one. Easily p1x. Okay, this value we know, right? This is just x. Okay, which is passing from origin. Okay, and then this is like this. This is for this is minus 1 by root 3, and this point is 1 by root 3. Okay, and this is for p2x. This value is p2x, and that value we know, that is 1 by 2 3x square minus 1, right? And similarly, and there is another graph for this. This is for right? This one, and this is for these points are uh, root 3 by 5, that is minus, and this is root 3 by 5 plus. Okay, minus root 3 by 5. Okay, so this is for p3x, and this value is uh, 1 by 2 5x cube minus 3x. Okay, these are the graph we can draw in x-axis and p-axis, right? This is about the legendary polynomial. So I have solved all type of questions, right, from legendary polynomial. So you can practice questions, uh, different questions using whatever I have taught you at the moment. Okay, so this is about the legendary polynomial, and next time we'll solve Hermite polynomial and Rodriguez polynomial and etc. in mathematical physics. Okay. Okay, guys. So before ending the class, I would request everyone who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are free and live and are going to help you to crack the exams related to physical science. Okay. Okay, guys. Thank you so much. Bye now.